Hello and welcome to my evaluation of a data set where I will analyze its information and create 3 models to predict if a customer is going to leave me or not. The first thing I always ask myself is, why do I care? Why does the world care? What's the impact? Well, businesses care if their customers leave them because there are many horrifying things that result from this situation. Lost jobs, lost profits, increased sales and marketing expenses, and of course, additional work created and lost productivity, and as a result, lots of increased stress. Let's look at just the most recent bankruptcies that have been around in the United States. Just last year, 2019, we have so many. FTD, Charming Charlie's, Payless Shoes, very big chain, and the list goes on. Forever 21, okay, they're on the list too. So we need to make sure that each business is evaluating customer behavior as they proceed with their marketing strategies and their finances. A little tidbit from a research institute known as CallMiner. And they mentioned that avoidable customer churn is costing U.S. businesses over $136 billion a year. CallMiner surveyed 1,000 U.S. adults to find out why consumer contact suppliers, how they were feeling when they contacted a call center, and which communication channels they preferred. And here are a few fun facts from CallMiner about how serious customer churn is, in addition to the $136.8 billion that's lost. According to CallMiner, 33% of Americans say they'll consider switching companies after just one single instance of poor service. And also, a positive thing is 77% of customers would recommend a business if they have a good experience. So it's always important to be evaluating how your customers behave. If we look at churn by sector, we see that banks average 20% a year. And the least amount of churn is water utility companies. Well, that kind of makes sense. And somewhere in between is you have your broadband internet supplier. It's a little bit surprising because people get so upset if their internet goes down, but I guess it depends on where you live and what your options are. Just to reiterate my slides, we're going to go ahead and start to analyze our customer data set, and our goals that we have are to determine metrics for the project, and obviously to reduce churn. How are we going to measure performance improvement? What's our success goal? We've got to set metrics for this, maybe reducing customer churn by 10% in the next 6 months, and understand what deliverables are useful for internal stakeholders. I'm going to show you this in a 5-step process as I analyze this data set. First, I'm going to collect the data. I'm going to analyze the data. I'm going to wrangle the data, which means I'm going to pre-process it. I'm going to split the data, and I'm going to resample my training data. I'm going to train and test my data. Training means I separate the data set into 70-30, and I train my model, and then I feed that model into a test data set and run some algorithms. And then, of course, I do an accuracy check at the end to see if my models were able to predict customer churn and how accurate they are. Now let's talk about the actual data collection process. For this example, I'm going to be working with a very simple data set. It's essentially 10,000 bank members in 3 countries and their parameters for the last 11 years. So we're going to go through that. You can see a glimpse of it right here. I have their credit scores, their geography, gender, age, 10-year balance, number of products at the bank that they're in, if they have a credit card through their bank, are they an active member, their estimated salary, and whether they actually left the bank or not. And I have to include a little motivating quote from Mr. John Tukey, who is a famous American mathematician. He's developed a few different algorithms, including the FFT algorithm, which is the fast Fourier transformation algorithm. And he is a big explorer of data as well, looking at it very carefully. So we will research him and follow his advice. Moving on to our second process, analyzing and exploring the data, and I'm going to throw in a null hypothesis, which we will discuss toward the end of this presentation. And I know this data set in particular is very incomplete and leaves lots of unanswered questions. A few examples of what I want to know is it possible to obtain balances over a period of time as opposed to a single date? And what date did the customer actually exit? What types of products are the customer in? Could they have exited from a bank and from the product and not the actual bank? So there's a lot of unanswered questions and data that we actually need. And at the very bottom, I'm going to pose my null hypothesis for training purposes. And my null hypothesis is I do not think that the bank balances to salary ratios affect customer churn. And we'll explore that later. Slide, I take my continuous variables, which are essentially non-categorical, means they're not like true or false, they're not yes or no, they're not a choice of like three countries, which the countries in this particular study are France, Germany, and Spain. And I just make a comparison to the customers who exited the bank, which are those customers in the orange box. This is a box plot. And immediately I noticed the biggest difference would be in your age, tenure, and balance. And basically that has somewhat of an effect, not something significant, but that immediately you can see that there are some insights there. My next slide, I'm going to be talking a little bit more about my findings as I'm analyzing my data set. And I don't see a significant difference in the credit score distribution between retained and churned customers. And regard to the tenure, the average tenured client is 5 years. And once they hit that 5-year mark, they have a lesser likelihood to churn. And I also noticed that of the 11 years of data that I have, years 2, 4, and 10 have higher churn rates than the other years. One thing that stands out is that the bank is losing customers with significant bank balances, which is likely to hit their available capital for lending. The average bank balance for a churn customer is $91,000 with an average bank balance of $101,465. And I also noticed that older customers are churning at a higher rate than the younger ones, which alludes to the fact that the bank may not have adequate service standards for older clients. They may need more attention. They may not be able to be effective using online technology, things of that nature. And something that is at the forefront of churn is noticing the age groups that are churning, and that stood out significantly as being the ages between 40 and 59. And here's a scatter plot that further illustrates the concerns about our age groups. We notice with the orange dots, we can easily see the trend here. If you look at the x-axis, you'll see the orange concentrated between the ages of 40 and about 65, and not a significant trend in balance, even though we do notice more concentration between the balances of 100,000 and 150,000. We have some outliers that have churned. It looks like a 40-year-old something, maybe a 40-year-old, maybe that's exactly right, with one of the higher balances of 250,000 has exited the bank. And if we look to our right, our estimated salary doesn't have any particular trend. The age group certainly does on the x-axis. On the y-axis, we don't see any particular concentrations of orange at certain salary levels. If you can take a little bit of a closer look at it, you might be able to detect something here. But that is what I've concluded with the scatter plot. Here is customer churn grouped by balance and separated by the three countries, France, Spain, and Germany, with Germany having the most bank members with the higher balances who leave the bank. France had the most bank members, period, and they had almost the same number of actual people leave the bank as Germany, but they also have a lot more people that are members. So percentage-wise, Germany had the highest members leave the bank. This slide is interesting. It'll take all your variables of your data and it will apply the Pearson's R to find correlations between variables. The strongest correlation I found immediately was there is a 0.29 correlation between age and our exit, which is our dependent variable, at 0.29. What else was interesting? If they were an active member and their age, like those correlated a little bit, we can see right here. And if there are negative correlations, that will show in your Pearson's R heat map. So it's a valuable tool to quickly analyze the data points that you have. I am working with a relatively simple data set. I didn't have to what's called impute any data. Most of the data was clean. I didn't have to backfill anything. I had to drop a few columns that were not significant to my study, namely the surname of the customer, their ID number, and the row number. So I went ahead and dropped those 3 data points. This is to show you what's under the hood and what's going on in Python. I'm now in my Jupyter notebook and I am showing you the libraries that were necessary to complete the analysis and apply the algorithms. So first thing I do is I put them into my Jupyter notebook and I scan in my CSV file using pandas. I look at my data points and I determine what type of formatting they are, what types, like are they an integer, an object, a float, what's in the index that I may not need. And I decide that I do not need the name of the bank member, their customer ID, and the row number. They're not going to be relevant to my study, so I go ahead and drop them. And then I move on to look at description of my data, check for outliers. My oldest bank member is 92, and the average age is 38 years, with a minimum age of 18. I also check the standard deviations and other related relevant data points, the average tenure, which I show is 5 years, standard deviations of the tenure, and bank balances and so forth. So I see that the average bank balance is 76,000 and the maximum bank balance is 250,000, not too high for a big bank, right? And then I check to see how many people have left the bank, the exact number of folks, which I see is 2,037. And then I start graphing, exploring my data, trying to look for insights. Emphatically, I do a pie chart, break it down by percent, and then I continue to look for correlations. I run a Pearson's R correlation heat map. The most significant finding here, if you understand how this works, is age related to churn, which is exited. It's 0.29. That's the most significant amount. The higher that is, the more the two relate. Second in line would be, let me see if I just scan that, would probably be their salary and their bank balance. What else can we find? If it's a negative, it's having a negative correlation. If it's a high negativity, it's significant. So let's continue on down the line. I look for longevities, the years in which most people have left the bank. I can easily see that it's in the second year, the 4th year, and this, what would be the 10th year. These are 0 index, so that would be the 10th year. And then continue on looking for trends. I like this little map I made. If this were a significant bank with locations throughout the globe, this would be very useful. You just click on it to find data points. That can be done in Python. There's a lot of advanced mapping now that we can apply. And then I make comparisons. Sometimes I'll combine variables, I'll group variables. Here I group by bank balance, and so on. Python makes it relatively easy to check for trends. Here it's very easy with the scatter plot that I created from their bank balance against their age. Orange indicates that that customer has left the bank. We can definitely see a trend here for age groups, the mid 40s to the late 50s, early 60s. You see a lot of orange dots of people that means they've left. And you can easily translate that over here when you look at the age at the x-axis, who has left the bank. And then we split our data points up and we divide it between train and test. I actually didn't divide it. I did the 70% to train my model and 30% to do a test on combining. So during my training process, excuse me, I will combine variables because I think that they're related to each other and look for insights that way. And we check again with other graphing tools so we can pick up other trends. This is these are some variables that I combined. I combined the bank balance with the customer's salary. Thought they were related. Pick up on some things here. And tenure by age basically is felt tenure was a function of age. We continue down the line and analyze and mold our data. And we discover that the highest number of churn, like I mentioned before, were in years 2, 4, and 9. Well, effectively, if you advance it 1 for 0 indexing. And then I will apply linear, actually, I will do logistic regression, support vector modeling, and random forest algorithms to see how well I did train the data and how well these will pick up on customer churn. So that is just a little bit of a glimpse behind what is going on in the background with Python and determining the best algorithm to apply to discover customer churn. Part of the data wrangling process is looking at your variables and see how they relate, if you can combine them to get ratios. If it would give you some more insights, you can do that. I, for instance, combined balance and salary. I divided balance by salary, I divided tenure by age, and credit score by given age. So we can see the result of this. I see some evidence that there's a slightly higher churn rate amongst those with a higher balance salary ratio. Now let's talk about scaling, or what I call in this particular study, normalization. Since I want my values to correlate with one another, I want to scale them down, kind of like when you're comparing distances and you're looking at kilometers and miles on 10 different maps. You want to make sure they're all using the same scale. Maybe they're all using kilometers or they're all using miles. And like when you have $100 and you're going to go travel, you want to scale that $100 and apply it to the economies that scale. Anyway, so I used a normalization formula, and I just subtract x from x, the minimum, and then I divide it by the x maximum subtracted by the x minimum. Next, I'm going to perform both hotkey encoding. I already did what was actually called previously hot label encoding, where I would change, like say if the customer did not have a credit card, it would be labeled 0, but I want to assign it a -1 to show a negative relationship more clearly. I also want to hotkey encode the variables that, for example, you have geography and it's France, Germany, and Spain. We want to assign binary values to those. So we do what's known in Python as hotkey encoding. Next thing I showed you briefly when I went over my code is my data splitting. we want to split our data into a training data set and a test data set. And I went ahead and used Python code, and I divided it into 70% to train and 30% to test. After I'm done training my data, I will apply what I've done to my test data set. This is an important process when you're working with data and you're about to apply your algorithm. You want to make sure that you build what's known commonly as a modeling pipeline, which I will put together to engineer the processes that need to be applied to any data and deploy them. So if my model is successful and I want to deploy it to maybe hundreds of years and 1 million data points, maybe 500 million observations, I want to create a pipeline so I can, once I import my data, I can easily apply what I have done to format that data. And that would be including hotkey encoding, hot label encoding, and scaling, like I just showed you previously. Now, I will now do the exciting part, which is I'm going to feed my data into an algorithm. And the 3 that I chose are random forest, support vector machines, and logistic regression. Now, we will use what's called the ROC curve plot, or area under the curve, just to take a look at how well the 3 models did. And it's a bit of a feat to really understand what the ROC curve is, and it basically will plot your true positive responses versus your false positive responses at different classification thresholds. So we set a threshold, usually it's like 0.5. So that means you're flipping a coin if your algorithm worked or not. If it's at 0.5, then your model or your algorithm is basically useless. You don't really know if it's helping or not. But it is important to understand that the higher the AUC, the better the model is at predicting zeros as zeros, which means no churn, and ones as 1, which means there is a churn in this particular case. Now what we've been waiting for, the winner of the 3 models, the SVM, the random forest, and logistic regression, who won? Well, the word goes to random forest. It had the best results with a 0.78, which means it is able to correctly classify the client data into a churn or no churn category 0.78 of the time. Now let's take a look at what did our random forest show us. What did it do? Here I give you a confusion matrix for random forest. We can see from our confusion matrix that our random forest model resulted in the following. From our 2,995 test samples, the random forest model found 2,387 predictions to be true positive, which is a no churn result, and 329 as a true negative, which is a churn result. Now I thought that I would put my variables that I was working with into what's known as feature importance. This can quickly and easily show me which of the features contributed the most to the least toward our churn. An obvious one was our age. That came in as number 1, and followed by credit scores and then tenure. Now, let's look at something that I posed at the beginning of this presentation, which was a null hypothesis statement. Do I accept or reject the hypothesis, which was I believe that the bank balance to salary ratio of each customer has little impact on whether the bank customer will leave or not? That was my null hypothesis. What I do to test this hypothesis is I apply the p-value. It's important to understand the p-value. Basically, we set a threshold. I set mine at 0.05, and I run a test to verify that I'm correct about my null hypothesis. To best understand p-value, I would recommend looking at this video. You can download my presentation and review this video. It's on YouTube and it gives the absolute best explanation of p-value. So the person uses flipping a coin as an example. So if you have a quarter and you flip it 8 times and it always lands on tails, there must be something wrong. And because the likelihood of that is very small, probably 0.001%. So you want to look at your hypothesis, which might say something like, I will get heads half of the time and tails half of the time, and maybe reject it and see what's going on. Let's take a look at my results of my p-value test, which I used in Python. My hypothesis stated that the balance salary ratio has no impact on churn. Well, when I run my p-test, I show that that particular variable is less than 0.05. In fact, it's 0.03, which means I will reject my null hypothesis and move toward what is known as an alternative hypothesis. Now let's talk about some of the conclusions from this study. Through my examination of the small data set, I did discover a few significant findings: that there was no difference in the credit score distribution between retained and churned customers. The older customers over 35 are churning at a higher rate than the younger ones. Bank members with an average tenure are slightly less likely to churn than those with either low or high number of tenure years. And furthermore, our data shows that customers with higher balances are churning at a higher rate, which is a cause for concern for their lending capability. The bank could benefit from offering special programs when, say, a balance of $75,000 or more receives a higher interest rate on a savings account, or maybe special investment privileges. Neither the product nor the salary has a significant effect on the likelihood to churn, and more females have churned than males, and more credit card holders churn, though most of the bank customers possess credit cards. Maybe the bank can implement a special incentive for their credit card holders. By looking at this study from A to Z, we have a lot of unanswered questions. And that relates to data. Would it be possible to obtain balances over time? What date did the customer exit? What types of products are the customers in? Could they have exited from a product and not the bank? Does the bank have an investment division? Did the customer simply retire and consolidate their assets elsewhere? Are there NPS scores to factor into the data? Of course, every business needs to perform analysis and take measures to prevent customer churn. That's the message here. Considering the cost of acquiring each customer, a study should be an annual requirement. Thank you for listening to this simple example of how to apply data science to data sets.